Okay, question about sound waves. You've got 4 statements and you need to pick out the one that's not correct. So A, sound waves can be refracted. Yes, they can. Sound waves are transverse. No, they are longitudinal. Sound waves can be diffracted. Yes, they can. And sound waves transmit energy. Yes, they do. Okay, part B. You've got an oscilloscope trace here with 3 full waves. So this is your first wavelength. That's your second wavelength, that's your third wavelength. So you treat an oscilloscope like it's a graph, and this is giving you your scales. So in the Y direction, you've got 1 volt per square, and in the X direction, you've got 0.01 seconds per square. Now this question wants you to find the frequency. So frequency is 1 over time period. That's a capital T for a reason. So time period is the time taken for 1 wave. So if this is 1 full wave, it takes 2 of these squares. Each square is 0.01 seconds. So your time period is 0.02, which gives you a frequency of 50, and they're very nicely given you the unit, which is hertz. So on the diagram, draw the signal for a quieter sound wave of higher pitch. So you need to change 2 things about the wave. Quieter is obviously to do with the volume. So the volume is linked to the amplitude, which is this part of the wave, down to the middle. So if it's a quieter wave, you need a smaller amplitude. But then you also need a higher pitch. So pitch is linked to frequency. If you have a higher pitch, you need a higher frequency, which means you need more waves per second. So a lower amplitude means that your peak should be lower, and a higher pitch or higher frequency you need to have more of the peaks. So any wave where it is smaller, but there's more of them.